plane flying horizontally at an altitude of 1 mile and a speed of 500 miles per hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. As you can see, the path of the plane and the radar make a triangle. We're using y to represent the altitude, and x to represent the plane's horizontal distance, and c to represent the distance from the radar station and the plane. The quantities given in this problem are dx over dt, which equals the speed of the plane, or also the rate at which its horizontal distance is changing, and that rate is 500 miles per hour. The next quantity given would be dy over dt, which is just 0, because y is a constant. Oh, dc over dt is what we are looking for. It is our Waldo. In this problem, y equals 1 mile and c equals 2 miles. Because our variables form a right triangle, we are obviously going to be using the Pythagorean theorem to find dc over dt. Our first step is to take the derivative of the equation. Implicitly, as Megan said. Now she is taking the derivative of each individual variable. The derivative of x squared is 2x times dx over dt plus 2y times the derivative of dy over dt, which is the derivative of y squared. And that equals the derivative of c squared, which is 2c times dc over dt. And dc over dt is our Waldo. Now that we have a differentiated equation, we are going to plug in everything that we know. So for dx over dt, we know that it equals 500. And for dy over dt, we know that it equals 0. We also know that c equals 2, but we do not know yet what dc over dt is because that is what we are solving for. So now Megan will simplify. And now she will isolate dc over dt. Now we're going to return to our original equation in order to solve for x. So we're going to plug in the values known for y and c and solve for x. And now we get x equals root 3. So now we plug in this value for x into the original equation. Oh, into the differentiated equation. And we get 250 root 3 equals dc over dt. So dc over dt equals approximately 433.01 miles per hour. So 433.101 miles per hour equals the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. And that is how you solve this problem.